right about to do example 9. So there's a method to my madness here. So if I want to do in letter A the limit as x approaches infinity of 3x minus 2 over the square root of 2x squared plus 1. All right, there is a technique we can use. And watch this. I know that if I could really get inside that square root, that the square root of x squared is going to be my absolute value. So watch what I'm going to do. I'm going to divide inside by x squared, but technically that's the square root of x squared is my absolute value of x, right? And up in the top, I'm going to divide this by x. Because right now I really can't figure that out because I've got 3 times infinity over a square root of 2 times infinity squared. So I'm not quite sure what's happening. So I'm going to use this technique that I am really multiplying the top by 1 over x and the bottom by 1 over x. Okay, let me say that again because this is kind of tricky. I am taking the numerator and multiplying 1 over x, and in the bottom, technically 1 over x, because it's 1 over the square root of 1 over x squared. And what I want you to notice is that if x is positive, then the square root of x squared is x. And I know that in letter A, x is approaching positive infinity, so x is in fact positive. So watch what's going to happen. And we're going to do a couple of these to try to get you a little more comfortable. So this is going to be 3 minus 2 over x over the square root of 2 plus 1 over x squared. And let's remember something we talked about yesterday. Do you remember this one from yesterday? The limit as x approaches infinity of 1 over x to the r power for some positive r, that's going to go to 0. So then in my numerator, what happens to 2 over x as x goes to infinity? It goes to 0. And what would happen to, even though there's a square root, what happens to 1 over x squared? It goes to 0. So this limit then is the limit as x approaches infinity of, whoops, now I'm letting those go. Let me put that in, sorry. Then that's going to just be 3 over the square root of 2. All right, so then let's look at letter B. We're going to do this again, but now I'm going to look at the limit as x approaches negative infinity. So I cannot directly substitute right now. That's going to be a problem because I've got what's called an indeterminate form. I'd have infinity over infinity. Again, that's called an indeterminate form. So then I have to use a different technique. And what I want you to note is if I have the square root of x squared, it's going to be the opposite of x when x is negative. So let me put this step in this time. So if I'm going to multiply by 1 over x to the numerator and denominator, well, and actually, this is actually negatives, right? Because when x is going to negative infinity, that's what's happening over there. But underneath, I squared it, so that's why those are positive underneath. So as I let x go to negative infinity, that square root of x squared is going to be a negative x. So then this is negative 3 over the square root of 2. Because this goes to 0 and this one goes to 0. Let's take a look at this graph. Yeah?
Why is it negative if you haven't taken the square root of x yet? Or the square root of x squared yet?
So I could do that, in the limit step. I could do that after. Because when I'm doing the 1 over x, then I could do it after the limit. You know what I mean? Like as I'm letting x go to negative infinity, then that's gonna approach the negative. Let's go ahead and press pause and let's take a look at this graph. If you have your graphing calculators, let's go look at y equals 3x minus 2 over the square root of 2x squared plus 1. So I'm going to grab my Desmos and pull this up. So I'm going to put y equals 3x minus 2 divided by the square root of 2x squared plus 1. There we go. So notice it does have a horizontal asymptote, and they're different depending on whether you're going to x approaches infinity or x approaches negative infinity. So that's why on the left side it needs to be the negative, because when you do the square root of x squared, that's the opposite of the x, okay? Like that's the y behind it. So do you see that on the right side? If I would calculate 3 divided by square root 2, that's the horizontal asymptote on the right. And on the left, it's the opposite of 3 square root 2. Okay? And remember, limits at x approaches infinity or x approaches negative infinity are the horizontal asymptotes. That's what we learned yesterday. Okay, so the definition of a horizontal asymptote is the limit as x approaches negative infinity of f of x equals this line, horizontal line, y equals L, or the limit as x approaches infinity of f of x equals L. So then let's take a quick look at example 10. This is using those 3 parts that we looked at yesterday and that tie into your pre-calculus. You're going to look at the degrees of your numerators and your denominators. So this one's just asking me for my horizontal asymptotes. So what you're going to do is you're going to look at the limit as x approaches infinity of f of x. And so that's 0. And the limit as x approaches negative infinity of f of x is 0. So in this case, and if we went and looked at the graph, this is really cool that we looked at the previous function graph. Most of the time, the horizontal asymptote is the same as you go to x goes to positive infinity or x goes to negative infinity. But sometimes it has two different ones, but that's usually going to happen when you have a square root of x squared. Okay, that's where you're going to get something different. Here, my horizontal asymptote is going to be the same on each end. Does anybody know what it is on this one?
2.
Good job. Y equals 2. And in this one, the degree of the numerator is greater than the degree of the denominator, so there's no horizontal asymptote. All right, so on this one, you're going to have to look at both the limit as x approaches infinity and x approaches negative infinity. Because of that square root of 2x squared. So let me pause and have you look back at example 9 and see if you can replicate that procedure. Let's see if we can't get it to make a little bit more sense. And this is why yesterday I stopped and said, because I'm going to explode your brains tomorrow, and I think I have a little bit. So we're going to let this gel a moment. Negative infinity. It's on the other side.
But you just put positive and negative?
Yes, you have to do it twice.
Okay.
Yeah, that's it. And let's make sure, as I'm walking around, we need to make sure we're doing proper notation. So when you're doing this horizontal asymptote, you have to have both limits. Okay, these are actually limits in order to determine the horizontal asymptote there. And good news, you don't need to rationalize denominators. So like on that last one that I had 3 over square root 2, I didn't rationalize it. You don't have to. All right, I'm going to go ahead and start this one. I'm going to do the right side. And so I'm going to divide by x. And so as x approaches infinity, the x values are positive. Okay, the x values are positive. So this is going to be the limit as x approaches infinity of 8 minus 1 over x over the square root of 2 plus 1 over x squared. So this is 8 minus 0 over the square root of 2 plus 0, which is 8 over square root 2. How many got that side correct? All right, okay, that's quite a few. All right, now let's go on the other side. So as x approaches negative infinity, so the x value is negative, okay? As you're coming in from the left side, the x value is negative, so that's why I'm taking the opposite where I'm plugging the dividing by x. So I get 2x squared, and the reason why I don't do it down in the bottom is that a negative squared is positive, okay? So then I'm getting the limit as x approaches negative infinity of negative 8 plus 1 over x over the square root of 2 plus 1 over x squared. So the equations for my horizontal asymptotes, let's not lose sight of what we just did. The horizontal asymptotes are y equals 8 over square root 2 and y equals negative 8 square root 2. So if you looked at the graph, it would have that wonky where the horizontal asymptotes, there's two different ones. All right, then let's look at example 12. Determine the equation of any horizontal asymptote if any of the graph of the given function below. F of x equals sine x over x. All right, so I'm not quite sure what's happening, so let's start with our definition. And I'm going to write down what I know. The top is going to oscillate between -1 and 1. And x is shooting to infinity. So what happens over time is, even if it's -1 or +1 over infinity, what is that going to? 0. And then what's going to happen on the other side? It's going to be the same thing, right? So I just have one horizontal asymptote of y equals 0.
How do you know it's 0?
Okay, let's do this. Do you remember our lovely squeeze theorem? Watch this. Let me start with something I know. I'm so glad you asked. So if I have that I know sine x oscillates between -1 and 1, I could divide then by x. Oh, this is a lovely review. We know the limit as x approaches, what was this, infinity, of -1 over x, that's 0. We know the limit as x approaches infinity of +1 over x is 0. So here's your squeeze theorem practice. Now you have to say that the two limits are equal and they equal 0 by the squeeze theorem. The limit as x approaches infinity of sine x over x is 0. So that's very precise instead of just saying, hey, it's oscillating and shooting. Nice. Nice. Okay. That was beautiful. That was beautiful. And now I have the song, Take It to the Limit, in my head. Yeah, exactly.
Can you use the 1 over x equals 0, like anyway?
Yes.
So couldn't you just split it up into sine x times 1 over x, and then it's just 0?
So let's try that. So you're saying the problem is I can't determine the limit as x approaches infinity of this one, because this one doesn't exist. That was a great thought, but it didn't work there because that one doesn't exist. Yeah.
I understand why 1 over infinity equals, or I know that 1 over infinity equals 0, but I don't understand why.
Okay, so do you remember yesterday, because that's when we went over it yesterday, is you could do a table, okay? You can do a table, and as you put, so we can just talk about it again. So look, if I have y equals 1 over x, and I start with 1 over 0.1, that's 10. And if I do, as I make it get closer and closer to 0, it's shooting to infinity. The closer the number gets to 0 and you're dividing by that smaller and smaller and smaller value closer to 0, then it's going to shoot to infinity. Was I going the right way?
Thought we were
Oh,
fighting
sorry,
wars.
yeah, I went the wrong way. So, sorry about that. Yeah, so let's say if I do 1 over 10, that's 0.1, 1 over 100, 0.01. So as I let the denominator shoot to infinity, yeah,
So
sorry.
is it approaching 0 then? Because it would never actually be 0, right? 1 over infinity?
Well, if you look at the graph, the definition of the limit as x approaches infinity is the horizontal asymptote. And it does approach y equals 0. Yeah. All right, let me give you a few minutes, and I want you to try, there's 1, 2, 3 multiple choice questions. Okay, these are from actual AP exams. So let me give you, 1 or 2 minute head start on me. On multiple choice, good news, you don't have to show any substantial work. Just do whatever jottings you need. And these are multiple choice where there's only one correct answer. All right, turn to your neighbor and check with them however far you got. See if you got the same multiple choice and discuss.
I only got the first one.
I said
I said E because, like, if you look at because it's, I forget what it is, but they're both x to the power 2. I think the degrees are the same, and then it's 20 over 4, that equals 5. I'm so proud of myself.
So wait, what did you put second?
All right, when you see horizontal asymptote, what should be registering in your minds? Horizontal asymptote.
Because X goes to infinity and infinity.
Good job, okay? What you should immediately be thinking of is the limit as x approaches infinity or the limit as x approaches negative infinity. In this first one, they were really trying to tempt you with this first one. It's not letter A. That would have given you, you'd multiply by 5 over 5 to do the limit as x approaches 0. Okay, so they were really tempting you here. This one doesn't even make sense. It's a line. This one has a vertical asymptote. What's wrong with letter D? What would be the limit as x approaches infinity here? Negative 5. So this one is E, and you are looking at the degrees, and you get 20 over 4, so that's y equals 5. All right, in the middle one, all right, this is where they're going to catch you. If I look at the limit as x approaches infinity of 5 plus 2 to the x over 1 minus 2 to the x, so this is really going 2 to the infinity over negative 2 to the infinity. So what would that be? Is it 0? Negative 1. And then watch what happens on the other side. If I plug in negative infinity, watch this, because the 5 over 1, I mean, when you're shooting to infinity, this isn't doing a whole lot. So I'm getting 5 plus 2 to the negative infinity over 1 minus 2 to the negative infinity. Now, of course, you know, it's really not happening there, but what's 1 over 2 to the infinity? 0. So this is like 5 plus 0 over 1 minus 0, which is 5. So this is letter choice E. All right, so let's talk that one through one more time. This is pretty advanced, and that's what the multiple choice, we're going to build ourselves up by the time the exam comes in May. But when you do horizontal asymptotes, if it's a simple rational function, you can do the degrees and that's it. This is not rational because I have an exponential in the fraction, okay? So then I've got to consider both directions. The limit as x approaches infinity and the limit as x approaches negative infinity. So when I have 5 plus 2 to the infinity, that 5 doesn't even, make a dent in the 2 to the infinity part. So I really have 2 to the infinity over negative 2 to the infinity. Whatever that number is, like say, 2 billion over negative 2 billion, it's always going to cancel down to negative 1. All right, then here's the third one. It says, what are all the horizontal asymptotes here? So let's look at the limit as x approaches infinity of 3 e to the x, and I like to rewrite my e to the negative x's. So this looks like 3 to the infinity. Oh, sorry. Sorry, no, I lost my e there. So then this is like 3 e to the infinity plus 0 over e to the infinity plus 0. So that would be 3. So do you see that I can now cross off some of my multiple choice options? Then let's go do the limit as x approaches negative infinity. So that's going to be 3e to the negative infinity plus 7 over e to the negative infinity over e to the negative infinity plus 1 over e to the negative infinity. Can you tell those pieces are going to 0? And so you get 7. So now that was letter choice D. Okay? All right, so I mean, I'm really ratcheting it up, okay? These are really going up there in terms of level of difficulty. All right, the last topic. These are actually not typically on the AP exam. We're going to do a real brief refresher. You did this in pre-calculus. If you have a rational function, f of x over g of x, and the degree of the numerator is exactly 1 more than the degree of the denominator, you have a slant asymptote. Sometimes it's referred to as an oblique asymptote. So all you do is either polynomial long division or synthetic division. I'm going to go ahead and do the synthetic. So then my slant asymptote is y equals x. And let me explain what happens, and I think now you'll have a better understanding than what maybe you had last year or in Algebra 2. I know it's hard to explain in Algebra 2 because we don't really talk about formal limits there. Do you understand that as x approaches infinity, this remainder goes to 0? That's why we don't include the remainder in a slant asymptote. Because as x approaches infinity, 4 over x minus 2 goes to 0.